In this lesson, we're going to look at system word problems. So let's talk about a couple things here. A system word problem will have two unknown quantities, and this will be something different than what we've seen so far. So you should be looking for two unknowns when you're setting up equations, and if you have two unknowns, like an x and a y variable, then you should be writing two equations. So the word problems will create two separate equations, but not necessarily in the same format. So for example, one equation might be given in standard form, or you might set it up in standard. The other might be in more of a slope-intercept form, but you should be writing two equations from your word problem. After you form your two equations, then you'll determine if it'll be best to use substitution or elimination to solve for those two unknowns. All right, sorry about that. Okay, so here's our first example. Swiss and Limburger cheese cost different amounts per kilogram. A box containing 3 kilograms of Swiss and 2 kilograms of Limburger costs $24.40. Another box containing 4 kilograms of Swiss and 5 kilograms of Limburger costs $47.50. How much is each type of cheese worth per kilogram? So in this example, we need to always start our word problems by determining what we're trying to solve for. So here we have two missing things. We are missing, and it's even asking us, how much is each type of cheese worth per kilogram? So that tells us we're looking for the cost of the two types of cheeses. Our types of cheeses were Swiss and Limburger. So that right there tells you our two missing values. So we're going to let x, and it doesn't matter which one you name, x or y. I'm going to name x as the cost of Swiss cheese per kilogram, and my y is going to be the cost of Limburger per kilogram. Once you've identified what your variables stand for, and you do need to do this before you write your equations, now we need to write two equations. We have two variables, so we need two equations to be able to solve for those and set up a system. So let's go back to the problem. In the problem it says a box containing 3 kilograms of Swiss and 2 kilograms of Limburger costs $24.40. Hopefully as you're reading that, you see that the 3 kilograms of Swiss, 2 kilograms of Limburger go together. They combine together to make $24.40. So if we have identified our Swiss as x and our Limburger as y, then if we have 3 kilograms of Swiss, that means however much Swiss cheese costs, if we're buying 3 kilograms of it, we're going to multiply that cost by 3. If the cost is per 1 kilogram and we have 3 of them, we need to triple it. So that tells us right there that to set up the equation, we're going to do 3 times x plus 2 times y, and that should equal the total, the sum, right, of $24.40. Following that same logic, in this next sentence, it says 4 kilograms of Swiss and 5 kilograms of Limburger costs $47.70. So that right there is your second equation. You have two variables. We've identified what our variables stand for. We now have two equations. We have set up a system that can be solved. So because our system was set up, both equations are in standard form. Neither variable has a coefficient of 1, so neither one's too easy to isolate. I would recommend using elimination method here. So take a moment and remember there's some different ways you can eliminate. So solve this system by elimination, find x and y, and when you're ready to check your work, let's come back together. Okay, so hopefully you just solved. If not, click pause and solve it, but if you are done solving, we should have found x's value to be 380 and y's value to be 650, meaning that Swiss cheese costs $3.80 per kilogram and Limburger costs $6.50 per kilogram. So Over here is really the final answer. This is why it is incredibly important that back here we identify what x and y stand for, because at the end of all your equation work, when you get x equals and y equals, you need to be able to tell which one is which. And so in this case, the x in our example stood for Swiss. So that's how I know at the end that that's the price for Swiss per kilogram and 6.50 is the price for Limburger. Okay, let's look at another one. Kaya wants to build a rectangular corral for her horse using picket fencing. To make the best use of the available land, the length of the corral must be 3 times its width. If Kaya has 210 meters of fencing and wants to use it all, what are the dimensions of her corral? All right, so in this case, in this word problem, we still need to start out by identifying what we're trying to solve for. And that usually comes from the question at the end. Here it's asking, what are the dimensions of the corral? We should have a question mark. What are the dimensions? So dimensions are length and width. So we are looking for the length and the width of the corral. Now, we're told that Kaya wants to build a rectangular corral. That is a big hint here. The shape of the corral being rectangular is going to help us with writing our equation in a moment. So we need to identify our variables. Let me build onto this, and then I'll get back to that note about rectangular. So let's just let x stand for the width and y stand for the length. You can use L and W. You still need to just say what everything stands for using words, width and length, written out. But I'm going to use x as width, y as length. You could use y as width, x as length. You could use w for width, L for length. That choice is yours. That's why we always identify our variables so everyone knows what we're using. Okay, now it's time to set up our 2 different equations. And this word problem isn't as clear to find the equations from as the last one. In the last one, it was very obvious that the Swiss plus the Limburger equaled a total. Here we have to use a little bit of logical reasoning, in a sense, to come up with our equations. So we're building a rectangular corral. If it's rectangular, a corral is kind of like a fence. That means it's going around a certain amount of land. Well, if it's going around, that's representing a perimeter. So what this is referring to, and the 210 meters of fencing total, is really telling us the perimeter here. So remember, the perimeter formula for a rectangle is P equals twice the length plus twice the width. So in this case, if we know that she, or Kaya might be a he, I don't know, has 210 meters total, that's the furthest we can have this fence go, is 210 meters as the perimeter. Now we established length was y and width was x. So right there, you would set your perimeter formula up as 210 equals 2y plus 2x, or 2x plus 2y. If you had that in a different order, it's fine. So that's going to be one of our equations. Now, to get the second equation, let's go back to the word problem. There is a sentence in there that tells us to make the best use of the available land, the length of the corral, remember length we named as y, must be 3 times the width. The width we named as x, right? So that equation, the must be, is where our equal sign will go. That is our second equation. So we now have our 2 equations set up. So the perimeter one, you will have to come up with on your own using some reasoning given in the word problem. So if it's telling you the shape of whatever, in this case the fence, you have to use the perimeter formula for that shape. Okay, from here, you're going to solve your system, and hopefully you recognize that y is already isolated, meaning this system would be most easily solved using substitution. So take a moment, click pause, solve the problem. We'll check our answers together. Okay, you have now solved, hopefully, and found the width to be 26¼ meters and the length to be 78¾ meters. And those are the dimensions of our corral. Okay, Here's our next example. Mr. Ayala bought 5 shirts and 3 ties at the clothes outlet for $102. Mr. Gilmore bought 8 shirts and 3 ties for $147. What is the price of a shirt and the price of a tie at the clothes outlet? So we've got to start by identifying our variables, figuring out what we're looking for. We're looking for the price of a shirt and the price of a tie. So right from there, let's name X and Y as that. I'm going to call my X the price of the shirt. I should have price here. And Y the price of the tie. That's just how I'm naming it. You can name it however you want, but that's why we label here what we're naming our variables. This one's very similar to that first one, so I want you to try to write your 2 equations on your own for, I'll give you a couple seconds, and then we'll check them together. All right, so 5 shirts and 3 ties total is $102. So if shirts was X, ties was Y, sorry, this changed color. That tells you 5 times X plus 3 times Y should be $102. And then the next combination, 8 shirts, 3 ties for $147. There's our 2 equations. Notice conveniently the Y's both have coefficients of 3. So all we would have to do is multiply one equation through by a negative to be able to eliminate those. So take a moment, finish solving, and we'll check together. So click pause and play when you're ready to go. All right, so you've worked out this system, hopefully using elimination method, and found X to be 15. So in this case, shirts are $15 and Y 9, so ties are $9. And that is the end of our lesson on some basic system word problems you'll be seeing. So with that, hopefully you can get started on your homework or practice more of these on your own.